If I want to approximate the area under a curve, I've already taught you how to do that by integration. You sketch the curve. In the interval 0 to 3, that means you take your x values from x equal to 0 to x equal to 3. To do that, to make a graph or a chart of drawing the graph, would say when x is 0, when x is 1, when x is 2, and x is 3. And for each graph point, I'll have to work out x squared plus 1, and then I get the y values. That's how you would have done it in junior cert 1, 4, 9, 0, or 1, 1, 1, 1, and 0 and 1, 1, 2, 5, and 10. So my sets of coordinates for this curve are 0, 1, 1, 2, 2, 5, and 3, 10. And that would allow me to draw my graph in that domain. So I was to draw a little sketch of that. I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have to go on this axis from 0 to 1 to 2 to 3. 0, 1, 2, 3. And if I put in my points 0, 1, 1, 2, 2, 5, and 3, 10. And it's a quadratic graph that would have this shape. Yes? If I have to get the area under that curve from 0 to 3, I now know I can integrate it, yes? And I've shown you how to do that. But I could split it up into a series of rectangles. And I could say that rectangle, and in other words, I could approximate it to being that rectangle, and that rectangle, and add up them 3 rectangles. Would I be accurate? No. Why? I'd be missing all of those triangles. Yes? So initially how they did this is they split it up into a series of rectangles. The area of this would be, what would the area of that rectangle be? Well, the base is 1 and the height is 1. It would be 1 square unit. And here the base is 1 and the height is 2. It would be 4 square units. Here the base is 1. What did I say? The base is 1 and the height is 2. The base is 1 and the height is 5. So I could approximate it to 8 square units. Do you understand that? Yes. How would I be more accurate? Well, I'd be more accurate if I made more rectangles. So I go up to 1, 2, 3, 4, 6, 7, 8, 9, and 10. And going this way, we'll go to 3, 1, 2, 3, 0, 1, 1, 2, 2, 5, 3, 10, and it's my same quadratic graph. Now, what would happen if I split each one of them into 2 rectangles? Now, what would I be missing now? I'd be missing that, that. Which would be more accurate of an answer? The second. And if I split it up into more rectangles again, the more rectangles I split it up into, the more accurate my answer would be. Oh. And this is approximation of the area under the graph, right? What would the area of this first one be? Well, the area of the first one would be the base, a half. The area of the first one would be equal to length by breadth, which is a half times. What's the distance from there to there? Well, what's the x value? A half. So when x is a half, this is the graph of y equal to x squared plus 1. So when x is a half, what is y? Isn't that what you're trying to find? What's the equivalent y value here? So when x is, I'm trying to find, as x being a half, I want to know what that distance is from there to there. Now what I'm looking to get the area of that rectangle. Alright? And that line is the same as that line. It's a half of 1, which is a half. It's the area of 2 I want you to get. How would I get the area of the second rectangle? It's length by breadth. What's the length of it? A half again, times. How high is that line there? Well, when x is a half, what's y? So when x is a half, what's y? A half to be squared plus 1, which is a half to be squared, a quarter plus 1, 5 over 4, which is 5 over 8 square units. Do you understand that? How would I get the distance from there to there? Well, when x is 1, what's y? How would I get the distance from there to there? When x is 1.5, what's y? How would I get the distance from there to there? When x is 2, what's y? When x is 2, what's y? 5. Yes? How would I get the length of that line? When x is 2.5. So I split it up into a series of rectangles. Any questions there? To be 100% accurate, I integrate. The area under that curve is the integral from a to b of y dx, which is equal to the integral. I'm integrating from what? 0 to 3. Of what's y? X squared plus 1 dx. And that will give it to you accurately. But initially, how did they work out the area of curve? They split it up into what? Rectangle. The narrower the base of the rectangle, what about their answer? The more accurate. Yeah? So they could go up every 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, and so on. And to this day, that method is still used. Because if I gave you a lake like that, yeah, and I asked you to find its area, you'd split it along some length, and you'd divide it up into what? Rectangles. Will you be 100% accurate? No. But if it's the area of a lake, you would trace your lake out and then you would work it out and split it up into rectangles. There isn't a formula for that curve. Yes? So there's any questions? So do you understand what the integration does? How you get the area under the curve? We can get areas to the x-axis, to the y-axis, and the area under that curve. How would they have done it previously? Broke it up into a rectangle. What about the narrower the base of the rectangle? Well, the more than you'll fit in. Therefore, the accuracy goes up. Have you any questions?